All right, let's talk about one of science fiction's absolute greatest hits, an idea that could literally unlock the entire universe for us, the wormhole. It's not just a faster way to travel, it's a bridge through the very fabric of reality itself.
But that gets us to the big question right away, doesn't it? Is this all just wishful thinking? You know, a bit of fantasy wrapped up in some really complicated math? Or could these cosmic shortcuts actually exist? Okay, let's get into it and find out.
So just imagine for a second you actually found one. It probably wouldn't be some big swirling vortex like you see in the movies. No, it would probably look more like a perfect sphere, kind of like a crystal ball just hanging there in space. And when you look through it, you'd see this perfectly clear window to a totally different part of the cosmos. If you were brave enough to step through, your old home would just shrink away behind you, becoming that same shimmering orb.
To even wrap our heads around how a window like that could be possible, we have to kind of toss out our everyday ideas about space. We have to start looking at the universe the way Einstein did.
See, for most of human history, we pictured space as this rigid, unmoving stage. Think of it like a hardwood floor, where all the events of the universe just play out. But Einstein's view was completely different and way cooler. He saw the universe as this dynamic, elastic fabric, almost like a giant waterbed. On this kind of stage, massive things like planets and stars don't just sit there. They actually bend and warp the fabric around them.
And this flexible fabric is what physicists call space-time. So here's the really crucial point. If this fabric can be bent and stretched, then maybe, just maybe, it can also be torn and patched together. And that idea, that you can connect two really distant points with a patch, that's the whole theoretical foundation of a wormhole.
Now, the very first version of a wormhole that ever showed up in the math was something called an Einstein-Rosen bridge. You can think of it as like wormhole version 1.0, a really brilliant idea that came with a few fatal flaws.
So here's how it's supposed to work. In theory, you take an object with a lot of mass, which, as we know, curves space-time around it. Then you compress it more, and more, and more, until space-time gets so incredibly warped that it just collapses in on itself. That forms a black hole with its famous one-way barrier, the event horizon. The math suggested that this black hole could actually be the entrance to a tunnel, an Einstein-Rosen bridge.
And this bridge connects the black hole to its theoretical mirror opposite, a white hole. So a black hole is a one-way street in, and a white hole is a one-way street out, constantly spewing matter into what might even be a parallel universe. So you've got an entrance and an exit. Sounds perfect for travel, right? Well, not so fast.
Yeah, here's the fatal flaw. That bridge, it is unbelievably unstable. It would pinch itself shut in the middle, almost instantly, so fast that not even a beam of light could make it all the way through. So if you tried to cross it, you wouldn't pop out in some amazing new universe. You would just get, well, crushed at the center.
Okay, so the first draft was a complete death trap. That means if we actually want to travel across the stars, we're going to need a totally different kind of wormhole. We need what's called a traversable wormhole. And for that, we have a very specific wish list. First, and this is the obvious one, it has to connect two different places. Second, and this is absolutely critical, it can't have any of those one-way event horizons that black holes have. We need to be able to go in and come back out. And finally, the gravity inside can't be so ridiculously intense that it would just rip a person to shreds. This brings us to what is probably the single biggest engineering challenge you could possibly imagine. No matter how you make one of these things, gravity is always trying to slam it shut, just pinching that tunnel closed and leaving you with two separate black holes. So, how in the world do you prop it open?
The answer, at least according to the physics, requires a brand new ingredient. Something so strange it sounds like it was lifted straight out of a comic book. It's called exotic matter.
Now, exotic matter isn't antimatter, it's not dark matter, it's something else entirely. It's this theoretical substance, and its one defining, absolutely bizarre feature is that it has negative mass. And that one little property changes everything.
You see, everything we know, you, me, planets, stars, it all has positive mass. And this creates an attractive gravity that pulls things together. Well, exotic matter would be the polar opposite. With negative mass, it would be gravitationally repulsive. It would create a kind of anti-gravity that literally pushes space-time apart. And that constant outward push is exactly the force you would need to prop a wormhole open and keep it from collapsing on itself.
And as totally wild as this sounds, physicists actually have a candidate for where this effect might come from.
It turns out that on the quantum level, even empty space isn't really empty. It's this boiling sea of particles and antiparticles constantly popping in and out of existence. It just might be possible to manipulate this quantum foam to create the negative energy effect we need.
So let's just imagine for a second that we figure it all out. We create exotic matter, we build a stable, traversable wormhole. What would that future even look like? And, maybe more importantly, what hidden dangers come with bending the entire universe to our will?
I mean, the possibilities are just staggering. We could put one end of a wormhole in orbit around Earth and send the other ends out into deep space. Suddenly, Earth becomes the central hub for a sprawling interstellar civilization. Entire star systems hundreds of light years away would be just a quick trip through a portal.
But, and this is a huge but, there is a dark side to this kind of power. Mastering space-time isn't just an engineering problem, it's a reality-breaking one. There's a fundamental catch that comes with every single wormhole you create. And here it is. Because wormholes don't just connect 2 points in space, they connect 2 points in space-time. This means they are also theoretically time machines, and that opens the door to all sorts of paradoxes that would just shatter causality. You know, the most fundamental rule of the universe, that an effect can never happen before its cause. A lot of physicists believe the universe actually has built-in laws to protect itself from this, which might just make stable wormholes totally impossible. Which leaves us right here, with our final question. Are wormholes a dead end? A fascinating little quirk in the math that reality simply forbids? Or are they a puzzle just waiting for a future generation to solve? A sign that the rules of the universe are even stranger and more wonderful than we can currently imagine? The answer, for now, is still out there, hiding somewhere in the fabric of space-time.